So I'm going to go over the FRQs in the test review for chapters 18 through 21. So number 21 says a 2011 Gallup poll found that 76% of Americans believe that high achieving high school students should be recruited to become teachers. This poll is based on a random sample of 1,002 Americans. So a couple of things here that we need to note that this is a percentage. So this is a proportion. More precisely, we're talking about a sample here, so we're going to use p hat. It's equal to 0.76. The sample size is n. Lowercase n is 1,002. They tell us that we need to find a 90% confidence interval. So this means that C equals 0.90 for the true proportion of Americans who agree with this, this sentiment. So we need to first define what the parameter is. Let P is equal to the true proportion of Americans who believe that high achieving high school students should be teachers. All right, so the name of the procedure, because it's a confidence interval and we have one sample, we call this a one prop, which stands for proportion, Z interval. Z means that it's the test statistic for normal distribution. So conditions, we need to check for three things in this order: randomization, independence, and normality. The randomization is the easiest because I believe it tells us that it is random. It tells us it's a simple random sample. So it's stated, simple random sample, so it's random. Okay. For the independence, we need to make sure that the sample size, which is 1,002, is less than or equal to 10% of the population, which is all Americans. Let me fix this real quick. All Americans. Okay, so this is good. This is good. For normality, we need to check to make sure that n, which is 1,002, times the p hat, 0.76. Whatever this number is, we need to make sure it's greater than 10. So I'm going to use my calculator real quick. 1,002 times 0.76. That's 761.52. It's greater than 10. And then we also need to do 1,002 times 1 minus 0.76. So that's 1,002 times 0.24. That's 240.48. They're both bigger than 10. So we have a large enough sample size. So large sample size. Okay. So then for our work, we need to show the work for the confidence interval. The confidence interval is always your statistic plus or minus your correct value times your standard error. The critical value is dependent upon your confidence level. Since our confidence level is 90%, we need to look at our formula sheet. Where's our formula sheet? Is that formula sheet? We need to take a look at table B. Maybe look at 90%. The number right above it is 1.645. So this is going to be our p hat, which we said it was 0.76, plus or minus 1.645 times the square root p hat 0.76 times 1 minus p hat, which is 0.24, all over the sample size, which is 1,002. So we can type this into our calculator. So it's going to be 0.76. Sorry, let's figure out what the margin of error is. 1.645 times the square root of 0.76 times 0.24 divided by 1,002. That's going to be 0.02219. Let me just double check with my physical calculator. Square root 0.76 times 0.24 divided by 1,002. 0.02219. So that's going to be 0.76 plus or minus 0.02219. So if you subtract first, you do 0.76 minus 0.02219, you get about 0.7378. And then if we add it, you should get about 0.78219. So that is our confidence interval. So how we interpret it is we say we are 90% confident that the true, and we're just going to reiterate the parameter, the true proportion of Americans who believe that high achieving high school students should be teachers is between 73.78% and 78.219%. To interpret the confidence level, this means that if we were to repeat this over and over and over again with the same sample size, so I typically start the sentence by saying, in repeated sampling with size n is 1,002, we expect 90% of the confidence intervals to capture